January 18th, 1966, 03:15 Zulu time. A Boeing B-52 Stratofortress sits on the alert pad at Seymour Johnson Air Force Base, North Carolina. Tail number 58-0256. Strategic Air Command. Chrome Dome. Airborne Alert Mission. Captain James Mitchell walks around the massive aircraft. 156 feet from nose to tail. Wingspan 185 feet. 8 Pratt & Whitney J57 turbojet engines mounted in 4 twin-engine pods beneath the swept wings. The aircraft weighs 488,000 pounds fully loaded. Fuel capacity 47,000 gallons. Nuclear weapons in the bomb bay. First Lieutenant Robert Chen checks the main landing gear. Flight Engineer Technical Sergeant David Martinez examines hydraulic systems and engine oil levels. The B-52 operates with a 6-person crew: pilot, co-pilot, radar navigator, electronic warfare officer, tail gunner. This is Strategic Air Command. This is nuclear deterrence made real. Chrome Dome. The mission? Maintain continuous airborne nuclear alert. B-52s orbit predetermined routes, remaining airborne for 24 hours. If ground bases are destroyed, airborne bombers can still execute their mission. 1/3 of SAC's bomber force maintains 15-minute ground alert. Another portion flies continuous airborne patrols. Chrome Dome routes circle the perimeter of Soviet airspace, close enough to penetrate quickly if ordered, far enough to avoid provocation. Today's mission? Depart Seymour Johnson, aerial refuel over the Atlantic, orbit holding patterns near the Arctic Circle, return after 24 hours. The crew has been on alert for 7 days, living in the alert facility. No contact with families. Ready to launch within 15 minutes of the klaxon. But today is scheduled departure, not an emergency scramble. The crew. Inside the cockpit, Mitchell occupies the left seat, Chen takes the right. Behind and below them, in the lower compartment, Major Thomas Wright serves as radar navigator. Captain Frank Morrison navigates using celestial navigation and LORAN. Technical Sergeant Paul Anderson operates electronic warfare systems. Staff Sergeant Michael O'Brien mans the tail gun position, a quad .50 caliber defensive system controlled remotely from the tail. The 6 men will spend 24 hours together in this aircraft. No relief crew, no breaks. Continuous operation. Engine start. Martinez initiates engine start sequence. The B-52G uses cartridge starters, explosive charges that spin the engines to starting RPM. Engine number 1. The J57 turbojet begins rotating. Black smoke erupts from the tailpipe as fuel ignites. The engine settles into idle with characteristic whine. Engines 2 through 8 follow in sequence. 8 J57s producing 13,000 pounds of thrust each. Total power, 104,000 pounds. The sound is distinctive. 8 turbojets create layered roar that resonates across the flight line. Ground crew disconnect external power. The B-52 operates on internal systems now. 4 independent electrical generators, 3 hydraulic systems, pneumatic systems for flight controls. Taxi and departure. Mitchell receives taxi clearance. The massive bomber begins moving. The tandem landing gear configuration, 2 main gear bogies in centerline, outrigger gear near wingtips, creates unique ground handling characteristics. At the runway threshold, the crew completes final checks. Flaps set, trim configured, all 8 engines showing normal parameters. Tower clears 58-0256 for takeoff. Mitchell advances all 8 throttles. The bomber accelerates slowly, heavy weight, long takeoff roll. Airspeed builds gradually. 100 knots, 120 knots, 150 knots. At 170 knots, Mitchell rotates. The nose lifts. The outrigger gear leaves concrete. The main gear follows. The B-52 climbs at 1,000 feet per minute. Gear retraction, flap retraction, clean configuration achieved. Strategic Air Command Operations, SAC, maintained continuous nuclear alert from 1960 to 1968. During peak operations, dozens of B-52s remained airborne continuously. Others sat on 15-minute ground alert. The operational tempo was relentless. Crews rotated through alert duty. 7 days on alert, 7 days off. Continuous readiness. The mission profile required precision, navigation to exact coordinates, timing synchronized with other airborne assets, communication protocols strictly observed, everything planned, everything rehearsed, everything ready. Climb to altitude. The B-52 climbs toward cruise altitude, 35,000 feet, above commercial traffic, below fighter intercept altitude in most scenarios. Morrison navigates using celestial sights and LORAN radio navigation. No GPS, no satellite navigation. Stars, radio beacons, and dead reckoning. The inertial navigation system helps, but requires constant cross-checking against known positions. Wright monitors radar, watching for other aircraft, checking terrain features against charts. Aerial refueling. 6 hours into the mission, the B-52 approaches the first refueling track. A KC-135 Stratotanker orbits at planned coordinates. Mitchell positions behind the tanker. The boom operator in the KC-135 extends the flying boom, a rigid, telescoping pipe that transfers fuel at high rate. Mitchell flies formation, maintaining precise position. The boom operator guides the boom into the B-52's receptacle, located on the fuselage spine just aft of the cockpit. Connection. Fuel flows. 9,000 pounds per minute transfer rate. The B-52 takes on 90,000 pounds of fuel. 15 minutes connected to the tanker. Then disconnect. The tanker departs. The mission continues. The Arctic orbit. 10 hours into the mission, the B-52 orbits holding patterns near Greenland, far from Soviet territory, close enough for rapid penetration if ordered. The crew rotates through rest periods. 2 pilots at the controls at all times. Navigator and radar navigator alternate monitoring position. EW officer maintains radio watch. The tail gunner sits in isolation, monitoring rear hemisphere through radar and optical sights. Temperature outside, minus 60 degrees Celsius. Inside the pressurized cabin, manageable but cramped. 6 men in confined space for 24 hours. Weapons systems. The bomb bay carries nuclear weapons. 2 or 4 thermonuclear devices, depending on mission profile. Megaton yield weapons. Strategic deterrence. The weapons officer monitors arming systems. The weapons remain safe unless specific arming sequence is completed. Multiple safeguards. No single person can arm, but the systems are tested continuously. Circuits checked, indicators verified, everything ready. This is the reality of nuclear deterrence. Constant readiness, continuous operation, always prepared for orders that, hopefully, never come. The return. 20 hours into the mission, the B-52 turns toward home. Another aerial refueling over the Atlantic, then descent toward North Carolina. The crew is exhausted but professional. No mistakes, no shortcuts. Procedures followed precisely. Approach to Seymour Johnson. Landing gear extends, flaps deploy. 8 engines throttled back to approach power. Touchdown. The tandem main gear contacts the runway. The outriggers settle. Thrust reversers deploy. Clamshell doors redirect engine exhaust forward, providing deceleration. The B-52 slows, turns off the runway, taxis to the alert pad. The mission cycle. Engines shut down. The crew deplanes. Another crew boards immediately. Different aircraft, same mission profile. The cycle continues, day after day, year after year. SAC maintains constant airborne alert. Mitchell and his crew enter the alert facility, debriefing, rest, then back on alert. 70 years later, B-52s still fly, modified, updated, but fundamentally the same aircraft that entered service in 1955. The B-52 that was supposed to serve for 10 years, that will likely serve for 100. The aircraft that embodied Cold War strategy, that maintained nuclear deterrence through continuous presence, that proved strategic bombing required not just technology, but endurance, discipline, and unwavering professionalism. The Stratofortress, still flying, still serving, still representing the longest operational lifespan of any military aircraft in history.